get started. I don't think anybody knew who he is, but thanks for coming. Brett will finish up here in a minute. We'll dive a little deeper into Concurrency. Just a couple of quick announcements. Lunch, so we changed the location. So on your feedback forms tonight, whether or not you were there at lunch today, we'd like to hear kind of what you thought about the location, just in general. If you weren't there, is it too far north? Not far enough? That kind of things. We're trying to nail that down and try and be consistent month to month. New website is up and live. We'd like some feedback on that. If you have any, we're going to assume that if you're silent, you're okay with it.
Best thing ever.
That's what I think. Thank you.
I think it's got to sell out there.
Well, of course it is.
Yeah, we saw the poll. You must have been one of those voters.
It's a great system, but seriously get feedback on it in terms of usability and that sort of thing. And we just have to accept the fact that it's PHP and move on.
That's feeds.
It does have feeds.
Okay.
Tulsa Tech Fest on the 19th and 20th. It's in Tulsa. It's, I think, $50 for the weekend. Is that right? $40 for, it's got an Agile.NET track and a Pragmatic Programmer track.
Where I will be doing my domain-specific language presentation again. If anybody missed it last time.
So there should be, it's got a predominantly .NET focus, but there should be plenty of stuff for Java developers there if you're interested in going. We hope to have a Java track this year, but just couldn't get anything put together in time. But we're going to make a concerted effort for next October. So if you're interested in presenting or in any way helping that, please let us know and kind of watch announcements on the Jug list. We'll try and get to that a little earlier than we did this year. Feedback forms in the back.
Sign-in sheet.
Tickets?
Sign-in sheets. Get a ticket.
You should do the Objectmentor thing.
There are, I think, 2 books to be given away tonight, so if you want to be in the drawing, make sure you get a ticket, put it in the can.
There are.
Sponsor.
Yeah, my company's sponsoring. I'll get to that as soon as you want me to.
Brett will, do I have everything?
Steering committee is when?
Steering committee will be roughly in 2 weeks. From yesterday, it'll be on a Monday probably. That seems to work best. We're meeting at Java Dave's at Rio and MacArthur.
If you believe that.
Yeah. I told you it was Tuesday.
Yeah, you did. So let's see. Wrong location. Wrong. They don't want me to show up. I understand.
So it should be on a Monday. Let's
meet at Brett's house.
At Brett's house.
It's not. I need to organize it. Really, it's with 2 dogs and a cat, a crazy 11-year-old dog.
And a Wii. That's a good reason.
Well, if you have to go, I can bring the Wii. I mean, have Wii will travel, man.
So steering committee, a couple weeks. Keep an eye out for the email if you want to give feedback, have input. That's the best way to do it. And if I don't have anything else, Brian. All right. Okay, so just a couple things. First of all, I'm giving away 2 more books. These are both by Bob Martin. How many of you are familiar with Bob Martin? Some of you. These are autographed. They're both autographed. So just there you go. I work for Objectmentor. It's Bob Martin's company. It's a consulting thing. As most of you probably know, I used to work for Valtech. Objectmentor is doing something similar, except that it's a smaller company, much smaller company, and we tend to do percentage-wise more agile stuff than Valtech. But that's just because Bob Martin was one of the key instrumenters of the Manifesto for Agile Development. So. There you go.
Do you have any courseware similar to your presentations?
It turns out we do. Yes, we have courses. We're right now. I've been busy lately working on this thing that we're doing. We're calling it blended learning, and it's a combination of some lecture and then online learning. And I've actually seen some of the online materials with online tests and assignments that you do online, and they get graded and all that kind of stuff. And that's what we're working on right now. In addition to mentoring and training and traveling all over the place. And we've got a couple of people of notoriety. There's obviously Bob Martin, who's been instrumental. I mean, I knew Bob Martin from the early 90s because I reviewed his first book on C++. And then there's a guy named Michael Feathers. I don't know how many of you have heard of Michael Feathers? Okay, a couple of you. He's got a really well-received book called Working Effectively with Legacy Code, which we gave away at lunchtime. And so there's a couple of pretty well-known people, and then there's the scrubs like myself. So if you're looking for consulting and training and mentoring, I suppose you can talk to me. We've got some stuff going on, but we're actually generally pretty busy. I've had an amazing stretch of 2 weeks at home. Yeah, it's great. It's so weird being actually at home on a weekday. It's nice. I can get work done. Okay, so that's all I'm going to say about Objectmentor. If you want, I can give you a business card. Any questions before we continue? Right?
What's the volatile keyword do?
Well, it turns out that's what we're going to get into next. Okay, so...
Okay, I have a more basic question then. Isn't synchronized evil?
Aha.
And I asked that question because if you use it in the wrong place, as soon as you have like a multi-user system and it's under load, doesn't it just slow everything down?
Okay, so let me give you a story. This is not my story, but this is I'm going to take it on as if it's my own. It's a story from a guy named Jerry Weinberg. Some of you may know that name. He was working back in California in the 70s, and someone had written some algorithm that had to do with, I think it had to do with validating license plates that had some kind of foul language. I don't know what. And this guy had written something that was really fast, but it didn't work. So Jerry came in. He rewrote the algorithm. It was substantially slower, probably an order of magnitude or maybe even more slower, but it was correct. The developer, in his defense, who had written the incorrect stuff, said, well, my stuff is faster. And so I just answered your question. Unnecessarily using synchronized is costly. However, it turns out that it's getting less and less costly. As Java 1.4 to 1.5 and 1.5 to 1.6 has come along, predominantly I think it's in the just-in-time compiler. The actual overhead of using synchronized has gone down. But independent of that, let's ignore actual performance. If something needs to be correct, it needs to be correct. So there are different ways to handle that. One way to handle that is you work within an environment that says, don't synchronize, we'll manage the threads, and just make sure that all your stuff isn't shared. That would be the EJB approach, right? And also servlets, really. That's sort of the mentality of servlets and EJBs. Don't share, don't synchronize, right? And that's fine. And if you can get away with that, then that's great. And in fact, really, most people are writing garbage in, garbage out. CRUD systems. That doesn't sound much better. Create, read, update, delete systems. And other than the possibly updating the same, say, record, reservation, or whatever, the likelihood of shared access is pretty small. And so you sort of take an optimistic approach as opposed to a pessimistic approach. Now, that's a really good sort of tie-in, and I'm going to come into that. So to answer your question, Barrett, synchronized in and of itself, I don't think is evil. But there are different ways. You can write non-blocking algorithms. You can also not share. A lot of times, if you can get away with not sharing, then that's the way to go. A lot of random number algorithms actually are blocking, blocking.
I've just seen a lot of use of it where it's just a crutch and duct tape on a bad
Well,
algorithm.
yeah, and that here's the thing. That's because people aren't sure what they're doing and they don't understand the semantics of their system, so they are being pessimistic. And I have more to say about that later on. But, for example, what I would do is, in general, if I've got something that might be shared, I want to push the locking as absolutely close to that data as possible, and I want to make sure that it's not possible to use something in an incorrect manner. And either through replication, no sharing, or putting the lock right there. And we've got an example of that coming up. All right. Now, volatile versus synchronized. Let me tell you about the semantics of synchronized. Synchronized, we already heard, guarantees that it's atomic. So as long as everybody is using the same lock, because you can say synchronized on a method, or I can say synchronized on an object reference. So I can create just an object, and then two completely unrelated codes can both lock on that same object. And if they both lock on that same object, then only one of them is going to run it at a time. And so long as that critical section, from when the synchronized starts to when it stops, in the case of this method, it's the curly brackets. Same thing with the synchronized, where you don't use it on a method, but you use it on an object, from the open, close curly brackets. That critical section is guaranteed to atomic. Now, to get to your question, at the time that you exit from that, anybody who reads data that was manipulated in that synchronized block is guaranteed to see that version. Okay, now what about volatile? Volatile does not give you an atomic operation. Volatile does not give you a critical section, but what it does do is it makes it so that once a volatile thing has been updated, anyone else who's reading that volatile thing will see the updated version. so you don't get a copy. Really underneath the covers, it's possible that a local variable might be stored in a register or read and stored in a register or something like that. The volatile keyword pretty much precludes that from happening. So if I, for example, have I have an object, and this is one of the more common uses. I've got an object, and in that object I've got a flag, stop processing. And I've got a method, stop processing, sets it to true. And then I've got a while loop, while not stop processing, do something. It's possible that if another thread modifies that Boolean variable, the thread that's running in that while loop will never notice it. It will never terminate. Now, I've actually not been able to get that to happen on any platform that I've tried.
Oh, I have.
Oh, have you? Okay, great.
That's exactly how I discovered the
What
logic.
platform were you working on?
Windows.
Really? Okay. Well, I haven't been lucky enough to see that fail. Unfortunately, I mean I like to see failures like that because in theory this can happen, and according to the Java memory model it can happen, but in practice it often doesn't happen. So if I simply put the volatile keyword on it, what that means is every time I go through and check that value, rather than copying the value and optimizing it so that it doesn't get read multiple times, it'll actually reread the memory location over and over and over again. So it's actually slightly slower, but it's a way to avoid synchronization. Because in that particular case, I don't need to synchronize anything. I can just leave it unsynchronized. And the next time I get to the top of the loop, someone might have changed it. It turns out if I set a Boolean, that's guaranteed to be atomic. And I mentioned this at lunchtime. If you set something that's 32 bits or smaller, the actual setting is guaranteed to be atomic. If I write a long, how many bits is a long? Come on, those of you who are certified. 64. Is it possible value on a long that the value could be partially overwritten and then updated by someone else?
Yes.
Answer, yes, it is. Yeah. So, but it's not. But for integers, booleans, chars, object references, those are all. I think object references are all guaranteed to be an atomic set. All right. But just because the value is set atomically doesn't mean another thread that's reading the value ever reads it again. But volatile guarantees it. So volatile is a way to publish changes to a variable. And synchronize guarantees publishing and also atomicity. Did I answer your question? Yeah. And sometimes volatile is used as a crutch as well. Turns out.
Just a less well-known crutch.
Yeah, it's not. I've never actually used it in practice. I tend to be more pessimistic, and I'll do synchronize. But we'll see some options here. Okay, so let's talk about op variables. For those of you who are not at lunch, how many of you have heard of the atomic variables? Excellent. Now, how many of you were at lunch again? Okay, so the people. Excellent. So this is new to Java 5. Okay, here is the exact same thing. This semantically works the same as the other thing. Now, I could make some improvements to this. I'm not going to get into the details of that. But atomic integer, notice I've got this method right here, increment and get. No synchronized here. And by the way, just trust me, there's no synchronized on that method. Not synchronized, so it doesn't require a lock. Guaranteed to work. Much faster than locking.
Why?
Thank you, Ryan. Someone else other than Ryan who was at lunchtime have that question? Or something along those lines? How the hell does that work? How does that work, Brett?
Wow.
Yeah. That's the way to take it. Okay, so here's the thing. And synchronizing is a form of pessimistic locking. You assume something is going to fail, and so you make sure it can't possibly happen. Now, how many of you work with a system that, say, uses a database? Okay. How often do you actually lock? Explicitly? Well, let me ask you this. Doing full ACID transactions. No, you don't. The default... Yeah. Well, no, it doesn't actually. You're not doing ACID. Well, you set your policy. You guys aren't set the policy for what's the
Serializable.
Serializable. You're not setting your policy to serializable, are you?
Probably not.
Probably not. Why don't you serialize access? Performance. If you need to guarantee a certain level of performance, often you'll put a version number on your object. you'll write the object out, but only if the version number is correct. If the version number is not correct, you identify the conflict, and you probably retry. That's an example. Well, what's that referred to? Well, that's merging. But in terms of locking, what is that? Is that pessimistic locking? It's optimistic locking. All right. It turns out that this operation is exactly that. As of Java 5, the Java 5 compiler will take advantage of an opcode that's actually available on most processors, most modern processors. And here's what it looks like. Conceptually, I'm going to get my current value, and then I'm going to compare it to my current value. And if it is that current value, then I'm going to increment it by 1. And if it's not, then I'm going to get the current value, try to increment it by 1. And I'm going to keep doing that until I successfully was able to increment it by 1. Now, if you have a lot of contention, I can sit there and spin a lot. Retry, 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 retry. And it turns out, if your processor does not support this operation, because underneath the covers there's actually an opcode that does something like this, then the compiler will simulate with the busy wait loop. But this opcode on the processor is an atomic operation.
You said we'll simulate it with what?
With a busy wait loop. It'll basically do an effect like this code almost in terms of in assembly. But it'll guarantee the same it'll guarantee the same semantics, but it could be a little less performant. However, in practice, you could potentially have synchronization problems. How often do they actually occur? How often does, for example, ++ value actually get interrupted in practice?
We run into it in production.
You actually do run into it. It does happen. But it's compared to how often it doesn't happen, it's very rare. Now, it doesn't make it right to say, well, we can ignore it. I mean, some people say, well, it happens so rarely. It's a problem with the system. I hate computers, so let's not worry about it. Right? You've gotten that kind of thing. If we want to make this stuff semantically correct, we need to guarantee that it works. Well, this is a way to guarantee it, and it just says, look, most of the time we're not going to have contention. So let's assume we're not going to have contention and find out if we did. That's all it does. It's optimistic locking with retry. It turns out on my machine, on parallels running Java 6, using the atomic integer versus using the synchronized method, the atomic integer got rid of 95% of the time of the test. 20 times faster. 20 times faster.
For a really long, many iterations.
Yeah, for either a million or, I mean, I did a billion, I think I did something like a billion or something like that, just crazy. It didn't take that long. And I didn't have the patience to wait for the other ones. I used a smaller number. But the bottom line is, if you can use something like this, a non-blocking version of something, it's a lot faster. Now, if you looked at the implementation underneath the covers, it might be a complex implementation. Who cares? This is a Java thing. If you need something like a counter, you should be using this if you're using Java 5. Don't use synchronized in this particular case. So notice, I didn't block, and I retried, as opposed to blocking. Questions about that? Okay. It turns out that a lot of the Java 5 classes use this kind of stuff, because there's atomic integers, there's also atomic object references. So, there you go.
What would that do? Atomic object.
I want to set it to the object from non-null to null if I'm the first one. So, for example, instead of double check locking, set it if it's not null. Now, you might create 2 instances, but the second one never gets used. Okay, now I'm going to talk about dependent state. Yeah, this should be good. So synchronized was the first way. We saw using an atomic integer. But let's say you didn't know about the atomic integer. Let's look at this very simple example. There's going to be an interesting conclusion. You guys, some of you have already seen it. First of all, iterable integer, that interface, if you implement it in Java 5 and above, makes your object eligible to be used in the new for syntax. It requires one method, iterator. This already implements iterator, so the implementation is return this. That's almost exactly what I said at lunch, I think. Okay. So here we go. I've got a has next. And this is whatever. It doesn't really matter. There's some kind of check. And then there's a change. Typically, when we iterate, we use both of these. While, has, next, next. Right? So let's actually look at an example of that. Here's an example of that. I'm not explicitly calling it, but it turns out Java 5 is right there in that for loop. While, iterator, dot has next, value equals next, go into the body of the loop. And do that over and over and over again. In a single-threaded environment, this is fine. No problem with that. It'll work every time. It'll work as expected. All right? Now, let's say I create a runnable. And you know as soon as I create a runnable, it's going to cause a problem if I'm not careful. I create a runnable, and here we go. In fact, I've even made it explicit, though this syntax is equivalent to the other. In terms of the number of methods to get called, it does the same thing. So there's really no difference. So while has next, get the next. What happens if I use this guy, this runnable, with multiple threads? What can happen to the iterator?
Armageddon.
It's not quite that yeah, okay, let's go with Armageddon. It's the binary equivalent, it's the equivalent of a cosmic ray striking a memory address and changing a value. And it happens about as often, it turns out. You could actually get, what could happen is, two threads, they're fighting it out. Thread 1 reads the current value. It increments it by 1. It's about to store it. So I had a 5, I'm now about to store 6. Thread 2 comes in, reads the value, it has a 5. It increments it to 6, it stores it. Thread 1 continues, it stores 6. That can happen. All right? Here's the problem. We've got two methods that are all working on the same value. So the state, I've got methods that are dependent upon each other through this common state value. So you're thinking, well, gee, synchronous update, I just put synchronize on it, right? Synchronize won't hack it. Synchronize will not solve this problem because synchronize, I go into the method, I acquire a lock, I come out. Someone else goes in, acquires a lock, they come out. So we both think there's a next. The first one goes back in, gets the next one, comes out. Now I don't have a next anymore. The second one comes in, gets the next, and comes back out again. Because I have two methods, has next and next, that really must be called in a critical section. I only want to get the next if there is a next. So those two methods are dependent upon each other. It turns out the iterator interface is inherently not multi-thread safe. Is that a problem? That's a loaded question. Is that a problem?
Maybe.
How often do you want to have multiple threads use the same iterator? Never. Turns out I've got an example that does. And I've already used this. Actually, I wrote a program, and I wanted to write this program anyway, but I wrote it with the intention of using it as an example of this class, where I read my Wikispaces page, and there's a URL you can go to that gives you 20 per page, name of the page, and how many times it's been hit. By default, it gives you the current month, but you can put in a different date or something like that. And what I want to do is, I want to know which page are getting hit the most, so if I need to, I can go back and maybe add more content. That's the theory. Now, in practice, I haven't used it, but that's the theory. I've got these, like, 420 pages. Divided by 20, what is that? That's 21 pages. Well, it turns out I can get all 21 of those pages simultaneously. It doesn't matter. And then I can process them. I use a lot of regular expression processing to process it. And then all I want to do at the end is put it into a collection, sort it, and list it by highest number. So as long as I get all 21 of those pages and put them into a collection after processing them, and I wait till all that's done before I sort it, it's all good. So this iterator really is a list of all the work that has to be done. And if I inadvertently iterate beyond the end, I start getting pages that don't have any content. So that's a real problem. And that kind of thing where you're going out to a work queue and getting a lot of stuff and then processing it. Here's another example. This is from 98 or something like that. I needed to convert a database. Someone had written an algorithm to convert a database from AS400, and their system used a single thread, but to get a record from the database, they would actually perform an exec, go out to a DOS shell, run an executable on a DOS machine, get a text file back from AS400, which would take anywhere from 30 to 90 seconds. And so it took them 26 hours to convert the database. That had to be done daily. Not making it up. This is actual thing. And so ahead of time, I could calculate the records I needed. So there's my concept of an iterator. Didn't matter the order in which I got them. They were independent data. And so what I wanted to do was I multi-threaded the acquisition. And I limited it to like 4 or 5, maybe 6 threads, because if I tried to make more than that many connections, the environment I was running on would fail. So I had a pool of threads that would go out and access the database, and then put these records into a queue. And then there was another pool of threads that would take them out of the queue, process them, and write them to the database. Now, it's a classic producer-consumer problem. Without any optimization other than putting in threading where there wasn't threading, what do you guess the time it took? Went from 26 hours down to?
How many threads?
I used a total of 5 threads here and maybe 7 threads here or something like that.
13 minutes.
High five.
12 and a half, 13 minutes. Wow. Yeah. That's a
guessing.
pretty good guess. Now, figure out. So what does that tell you? 13 minutes out of 26 hours is some percentage. It's like 97%. So in terms of concurrency, that program was only 3% efficient. 97% of the time, it was not doing anything. Which, if you're using that machine for lots of other things, is great for other people. Right? So all I did was I used some threads to use that idle time and squeeze out concurrency. So that's, in fact, turns out the exact same problem. Right? The producer-consumer, there are 3 classic problems in computer science. And if you understand the solution to these classic problems, these algorithms, that covers probably most of the concurrent situations you're ever going to come up against. And the 3 are producer-consumer. And the thing there is, between the producer and consumer is a bound buffer. And knowing how to properly block when if it's empty on a get, and block if it's full, and also clearly terminate. If you understand the algorithm, that covers a lot of situations. The other 2 classic problems are readers-writers. And readers-writers is, how can I avoid starvation? Because writing is expensive, reading is not expensive. So if I always let readers go, but not writers, writers might get starved. But how do you balance that? Okay, readers-writers. And then the third problem is dining philosophers. And the dining philosophers is about deadlock and also starvation. And there are different ways to solve dining philosophers, readers-writers, and so on, that take into consideration different responsiveness, different CPU utilization, and so on. So if you research, if you really want to get into multi-threaded programming, research those 3 algorithms and write them. And if you've done that, then that will probably cover most of the situations you're ever going to come across, really. All right. Anyway, I'm going down different rat holes.